Okay. Apologize for that technical mishap. But so, just to reiterate, go over what I had said, uh, we have been investigating uh, a technology we've developed that's based around quartz and the particularly um, unique properties of quartz. So we have a quartz crystal that's hydrothermally, synthetically grown in the laboratory. It's pure quartz, electronics grade, optical grade quartz. Now, it's cut to a very specific geometry. It has very specific ratio relationships and how it's cut. You can see we have a tetrahedral geometry, and that's important because uh, the kind of fractal resonance across scale, because at the molecular level, quartz is tetrahedrally coordinated. Not only do the single molecules form tetrahedrons, but the intramolecular configurations are tetrahedral coordination as well. And something important to note about this is that uh, silicon, which is the central element of quartz, has the same valence electron configuration as oxygen. So it actually has a very similar binding pattern. Because of that, it has the exact same valence electron configuration. So water forms this same structure. So there's kind of a structural resonance between quartz and water. So we take these precision geometric quartz, PGQ, and we treat them with a uniquely shaped, circularly polarized electromagnetic field. This is produced by this device here. It's an electromagnetic resonance generator. It's referred to technically as the harmonic flux resonator. And what it does is it sets up a very specific pattern of EM field uh, emissions, uh, which we expose the PGQ to. Now, quartz has a electromechanical axis, which imbues it with the property of the piezoelectric effect. So with the piezoelectric effect, when there is mechanical pressure along the electromechanical axis, it generates a current. And this is how quartz forms the central timing unit of a central processor like you have in your computer, because of the very specific oscillations that will occur when you pass a current through the electromechanical axis. Well, similarly, when you pass this uniquely circularly polarized EM field through the crystal, it's theorized that it's going to cause that electromechanical axis to oscillate, almost like you're pumping the crystal. That's going to generate a charge, and because of the particular way that it's done, we theorize that it imbues the PGQ with a constitutive phonon activity, which along the electromechanical axis will cause constitutive emission of EM. This sets the crystal up with a EM field. And we believe that it's through this EM field that is uniquely patterned that the crystals have maximal effect, particularly on interacting with water. Because I'd already mentioned the structural resonance between quartz and water. Well, water, as you know, is a partial dipole molecule, so it responds to EM radiation. It's partially polarized. So the EM field of interaction of the PGQ, we believe, should have an effect on the water, changing its particular properties and perhaps even its intramolecular structure, the structure of the water itself. So to test this, we did plant tests where we give treated water to plants, and we also did direct measurements of the water using electrochemical impedance spectroscopy. So in one of the experiments we did, we've got this linear array, and we put 16 crystals in one, 8 crystals in another, and 1 PGQ, and then we have a control with no PGQ that have been activated with the electromagnetic resonance generator. These then are placed into the channels securely. Water is passed through the channels and distributed to plants in a very equal distribution pattern. So the only thing that the plants are receiving is water that has passed over the PGQ relatively quickly. And what we see is that with each increasing number of PGQ of which the water is exposed to, we see an increase in the growth rate and growth density of the plants, going from the control with no PGQ to 1, 8, and 16. And so quantification of this, we see what you could call a dose-dependent response, where with increasing numbers of PGQ that the water is exposed to, we see an increasing growth rate. So this is the average stalk length of the plants over time. And at the bottom, you have the slowest growth rate in the control. And then concordantly with increasing number of PGQ, you see increasing growth rates, with the highest growth rate occurring in the water that's been treated with 16 PGQ. And so, of course, since it has an increased growth rate over time, it's going to have a larger average stalk length. So these are the average stalk lengths. So the number of measurements that we're taking is about 30 individual point measurements, and then we average that together, do the standard deviation from it. So this is an average, and we repeat the experiment many times over, and this is what we see. But you can see with the group that's treated with 16 PGQ, it has the largest average stalk length, and this is concordant with the number of PGQ, with the lowest being the control. And so, for instance, that means with the test group that got water treated with 16 PGQ, there was a 254% increase in the average stalk length. Now, what that implies, among other things, is that the water is having some kind of beneficial effect on the living system, on the test organism, in this case, the plant. So, if the plant's only receiving water that's been treated with the PGQ must be affecting the water. And that is perhaps how it is having such a beneficial effect on the biological system. Now, we've measured numerous parameters, growth rate, immune response, pathogen resistance, increases in phytonutrient content, seed and fruiting body production, and all parameters that we've measured, we see an increase in the test groups that are treated with the PGQ MEM water. So we wanted to see what exactly is changing in the water that could have this kind of beneficial effect that we see in the response of the living system, the test plants. So to begin to probe what kind of changes might be occurring in the water upon exposure to the EM field of the PGQ, we performed electrochemical impedance spectroscopy, which is essentially a method by which an AC current is passed through a water sample, and it's passed through with increasing frequency, and you measure the impedance across that frequency spectrum. I don't know if, Scott, you want to say anything about that? It must be okay. 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 I have our electrical engineer with me, so if there's anything related to impedance, conductivity, AC frequencies, I try to defer to him to make sure I'm saying it correctly. In this experimentation, we're treating water with one PGQ. The water is placed in these EM shielded Faraday canisters, tubes, and within these there is one PGQ quartz crystal and one with a control that is untreated water. Now, when we take the electrochemical impedance spectroscopy measurements, what we see, and so this is again an average impedance value. What we see is that the control has a higher average impedance over our test unit, the PGQ that has been treated with the uniquely structured EM field. So our PGQ test unit will have a lower impedance value, a significantly lower impedance value than the control when we average over all measurements. Now, we also tested PGQ that had not been treated with the uniquely structured electromagnetic field. So these are PGQ, they haven't been activated, so to speak. They haven't been placed in the proximity of the electromagnetic resonance generator. However, even with the PGQ that have not been treated with our EM approach method, we see a lower impedance value in the water as compared to our control samples. And so this is an average impedance response across frequency spectrum. And we start with a lower impedance value in our treated water samples, and with increasing frequency, the impedance goes down. However, the PGQ is always decreasing at a rate that is much larger than the control, giving it a lower impedance value. When we take the PGQ that haven't been treated with the EM field and our PGQ that have been exposed to the circularly polarized EM field, and we run this experiment again, we see that our EM treated crystal group is causing the water to have a very low impedance value, whereas the control has a very high impedance value, and the PGQ that have not been activated, so to speak, with the EM field have an intermediate impedance value between the untreated control and our PGQ-MEM treated samples. Now, what this implies is that the crystal, the PGQ, the quartz crystal, which we have measured to be electromagnetically active, is interacting with the water samples and causing some kind of change in the physical properties of the water upon exposure to the PGQ. Now, this is ultra pure water, so any changes in the impedance value, any change in the electrochemical behavior of the water is not going to be due to the introduction of ions into the system or the absorption of atmospheric gases, all of which will change the electrochemical behavior properties of the water. But instead, it is most likely due to a phenomenon known as self-ionization, where the water molecule is able to have protons that are delocalized, essentially, so that each water molecule in the aqueous matrix is sharing protons, and what that causes is the generation of hydronium and hydroxide ions, which is going to change the conductivity or impedance of the water. So in our PGQ-MEM treated group, when we see a decrease in the impedance, that means that there's an increase in the electrical conductivity of the water. Now, the electrical conductivity of the water is due to ions in the water. That's what can transfer that charge. So if it has a higher conductivity, lower impedance, which is what we see, then that is due to most likely increased self-ionization rate, which translates as basically increased proton mobility of the water sample. Now, increased proton mobility is going to be important when that water goes into the biological system because it's possible that it will facilitate the exchange of energetic and even information signals intracellularly, which will result in an improvement in the vitality and functionality of the biological system or the intracellular environment. So the increased proton mobility of the PGQ-MEM treated water is going to possibly facilitate greater energy exchange and information exchange in the body, which is why we see such great increases in the growth rate and other parameters of vitality associated with our test plants. So that is the extent of the testing that we've done so far. I don't know if there are perhaps any questions that I could answer. Yes. It's Raphanus sativus, which is a radish. Actually, um, there's several different kind of measurements you can do with the radish, which makes it a great test plant. For one, it has one of the quickest germination rates. So you can run this test in a couple of days, collect a statistically significant amount of data, then run the test again. So there's a very high turnover rate, which is important for us. But because of the extremely fast germination rate of radish, Raphanus sativus, it makes it a great marker to measure the stalk length growth. But as well, we can do, and we have done spectrophotometric analysis of the leaves, where we have documented increased levels of phytonutrient concentration, particularly increases in chlorophyll content in our PGQ-treated plants. As well, we can allow the plant to go to maturation and measure the seed production. And we've seen like a 444% increase in seed production in our PGQ treated group as compared to a control. And then as well, we can measure the fruiting body, the radish, to see if there's any difference in the PGQ treated group as compared to the control. And on average, what we've seen is about a 250% increase in the weight of the radishes that are grown, that are derived from the PGQ treated groups. So, there's all these different markers of vitality that we're able to assess in a relatively simple test organism, the plant.
William? Yeah, that's you did a great job.
He's so nice to me.
and I wanted to just say a few things. The PGQ MIM that we're talking about is actually this crystal that we're sponsoring here as well, the ARC crystal. And this is the part that goes in the water, the new one that goes in the water. The ones that we tested here were linear arrays. And I just also wanted to say that William has been doing experiments with these plants and other plants for the last 6 years. There's been well over 1,000 studies, controlled studies with plants showing direct effects of the crystals with the plants and indirect with water. So this is just watering the plants where the water just passes in milliseconds over the crystals, and each time it's watered, it gets a little bit of water, and you can see the results. These are just the most recent experiments that we've done, but we've been doing these over 6 years and with crystals, and notice that we're all wearing these crystals as well because we know that it has health effects on humans, but we don't really report that because we're not studying that right now. But anyway, I just wanted to say a few extra words to embellish what you had said. Thank you.
Thank you, Scott. Yeah, so we've done thousands of tests looking at does it affect the plant growth, mainly just because myself, and Scott included, are very skeptical. So it takes a lot to convince us that our own product is, in fact, having a result. So some of what I presented today is just our most latest iterations of characterizing the effect of the PGQ on the living system.
And frankly, we were really surprised at these results because everyone thought before now that you had to expose this water for many hours before watering the plants. This is exposing the water for literally milliseconds, less than 1 second. Each time the plant is watered, and you see terrific results that are similar to the ones where we put the crystal under plants, or we run the water continuously past a crystal in other studies that we've done, or we put the crystal underneath, like we did one that was a 1 meter square of wheatgrass, and you could see the wheatgrass going like this across that, where the crystal was underneath the center of that meter. And so the center, 30 centimeters or so, was much higher, and the peak of that was 3 times higher than the periphery.
We have done blind tests. Actually, some of the first tests we did were blind tests, where we had one of the office assistants in the lab prepare a black box, essentially, where we had several boxes, literal boxes, where either a crystal was placed in or like a rock. Assuming that a rock shouldn't really have this same effect, one would hope at least. And then these were labeled, and even in blind testing, where I don't know which group is which, we actually see this exact same curve with our blind testing. Now, it's something that at this point we want to have independent laboratories do this same testing and do it with blind testing, so that it's almost, we've completely removed any potential bias, because it's an independent group replicating the experiment using our blind study, and so that's something that is ongoing. We're working towards getting that data completed. In further other testing we had done, now you can see we place the crystals when we're doing our EIS measurements. We place the crystals into a Faraday cage. A electromagnetically shielded container. So this keeps the water and the crystal shielded or separated from the ambient EM fields. Now, one of the reasons we do this is that in plant tests that we had done, where we placed the crystal into a electromagnetically shielded container and then tried to treat the water or tried to treat the plant, the effect was completely obliterated. So, this strongly indicated that whatever the effect was, it was due to EM interaction, that is interaction via the electromagnetic field. And so, since it appears to be mediated with the interaction between the PGQ and the water via the EM field, it's important that we actually shield the interaction during testing to control for any kind of ambient EM that could perturb the interaction. I thank you all for listening.
Thank you very much. Moля Винсент за презентация на Crystal Blue Enterprise. please